The circuit shows an ideal diode connected to a pure inductor and is connected to a purely sinusoidal 50 Hz voltage source under ideal conditions. The current waveform through the inductor will look like in the circuit. This is AC voltage, and there is a diode and an inductor. The current passing through the sinusoidal source, it is supply. So can I write down supply current is is. That current passing through the diode anode to cathode, I am representing it is id, and the current passing through the inductor, I am indicating it is il. If you look at it, source current, diode current, and inductor current all are same. Is is equal to id is equal to il. Too many variables are confusion, so I'm indicating by simple il. If I'm deriving the expression for this one, I will get I is equal to Vm by omega L into 1 minus cos omega t. Now I'm taking omega t is equal to different instants. For any periodic waveform, you are taking up to 360 degrees. If I am taking omega t is equal to 0, the current will becomes 0. Why? Because omega t 0, cos 0, 1, 1 minus 1, it will be 0. At 90, if I am taking, the current will be I is equal to Vm by omega L. Why? Cos 90, it will be 0, and the value will becomes as it is Vm by omega L. At omega t is equal to 180, I is equal to 2Vm by omega L. At omega t is equal to 270, and the current is equal to it is Vm by omega L. At current is equal at omega t is equal to 360 degrees, the current will be it is 0. What you need to do for all these instants, you need to substitute omega t is equal to in this, so that you will get all these values. Now if I am plotting the current waveform, with a span of 360 degrees, the current waveform will be coming like this. Now it is 0, this is 180, and this will be 360. This is source current or inductor current or diode current, all are equal only. At 0, the current will becomes 0, so I'm plotting here. At 90, if I'm drawing here, at 90, the value will be Vm by omega L. If I'm taking here, it is Vm by omega L. If I'm taking at 180, the value V is, it is 2Vm by omega L. If I'm taking at 270, the value will be Vm by omega L. At 360, the value will becomes 0. Now I need to calculate what is a Vm by omega L value. Now if you look at the equation, you know that supply voltage is equal to Vm sine omega t. What is Vs they have given? It is 100 sine 100 pi t. That means that if you compare this equation and this equation, Vm is equal to, it is 100, and omega is equal to, it is 100 pi. Now it is 100 pi. If I am calculating, it is Vm by omega L. Vm is 100 and omega is 100 pi. L, if you look at it inductance, this is 0.1 divided by 0.1 divided by pi. If I'm substituting here L value 0.1 divided by pi. Pi get cancel, 100 get cancel. It is 1 by zero point 0.1. That will becomes as it is 10. Now, if I'm taking here, it will be 10 amperes, and it is 2 Vm by omega L. This value will becomes 20 amperes, and this value will becomes as 10 amperes, and this current will be 0. Now, if you look at it, it is on the x-axis. If you are looking at, it is 360 degrees you are getting, but the examiner may be giving in terms of degrees or in terms of radians or in terms of time period. If I am taking in terms of radians, this value will be pi by 2 radians. It is pi, and this will be 3 pi 2, and this is 2 pi. Now, what I need to do here, if I am taking in terms of time period, at any 360 degrees, this will be total time period. If this is total time period, this will be t by 2, this will be t by 4, and this will be 0, and this is 3t by 4. Now, what I need to do, in the circuit, they have given the supply frequency is 50 Hz. Whenever the frequency is 50 Hz, what I need to do, the time period is equal to 1 by frequency. 1 by, if what is the frequency they have given, 50, then this will be 20 milliseconds. Whenever it is 20 milliseconds, this will be 20 milliseconds, and the examiner may ask in terms of degrees, in terms of radians, or in terms of time period. Now, if they are asking in terms of time period, what is the frequency they have given? 50 Hz. Whenever they have given frequency is 50 Hz, then time period is equal to 1 by frequency. What is the frequency here? That is 50 Hz they have given, then I will get it is 20 milliseconds. If it is 20 milliseconds, what is the time period? I can write down it is 20 milli, and what is this one? At 180 degrees, it is 10 milli, and at 90, it will be 5 milli, and at 270, it will be 15 milliseconds. That means if they are asking in terms of time period, at 10 milliseconds, it has to show it is 20 amperes. And the current at 360, it should be 0. That is, 360 means it will be 20 milliseconds. Now, whatever the question they have given in the gate, the current waveform should follow in this way. A 20 milliseconds duration, and the 10 milliseconds, it should be 20 amperes.